carbon dioxide in the Earth's atmosphere doubled it, and the temperature of the Earth would increase by 1 degree Celsius, according to Dr. Roy Spencer, PhD, who works for NASA as a climatologist. However, you rotate the Earth just 23.5 degrees, and you have the difference between a nice warm summer morning and a freezing cold winter Christmas Eve. 23.5 degrees. That's the difference in the Earth's rotation relative to the sun between summer and winter. And that difference is the difference between pouring water on your car and seeing it freeze and seeing it boil. So just that small little difference in the angle of the Earth makes such a big difference in the temperature outside. And yet we still wonder, what is the main cause of climate change on Earth? So comparing the Earth and the Earth's atmosphere and the sun is like comparing a hot dog, a grill it's on, the air around the hot dog. Basically, when you change the temperature or the amount of air around the hot dog, it's not really going to change the temperature of the hot dog. When you change the temperature of the grill, the hot dog temperature is really going to change. The same goes for the sun and the Earth. When the temperature of the sun increases, the temperature of the Earth also increases. And we see this historically. So I've been studying climate change throughout high school. It's been a subject of interest to me. And many of my friends think I'm crazy because I don't believe humans cause global warming. But really I'm just someone who took the time to do my own research and make my own conclusion. And I believe that global warming is not caused by humans, it's caused by the sun. So today I'm going to tell you what the significance, or how, well first I'll tell you the significance of climate change is something that impacts us all. And knowing what causes climate change is really important for individuals and policymakers because it can have a really big impact on the economy. So how sunspots affect the temperature of the Earth is what I'm going to tell you today. So first of all, I'm going to show you astronomical evidence for how sunspots affect the Earth. Then I'll show you dendrochronological and stratigraphical evidence, which is basically tree ring evidence and evidence found in layers of sediment in the Earth. And third, I'll show you ice core groups, which demonstrate how the sun affects the temperature of the Earth with CO2. So sunspots are basically dark spots on the surface of the sun. And they're darker because there's basically this magnetic field inside the sun. And when it extrudes beyond the boundaries of the sun, it creates this effect, kind of like a horseshoe magnet, where you see the particles try to line up with this magnetic field. And basically this causes friction in the particles and causes the temperature of the sunspot to decrease to about 3,000 to 4,000 degrees Celsius. So this decrease in temperature causes this dark sunspot that we see on the surface of the sun. So sunspots occur in these solar cycles that happen every 11 years. Here's one that happens from 1996 to 2006. And as you can see, solar activity has a minimum in 1996 and increases until 2001 when it peaks. And by 2006, it's once again at a cool. And this is on the NASA website, you can find it yourself. And this happens every 11 years. And there's also bigger solar cycles that happen over hundreds of years and thousands of years. And these are basically the main causes of climate change on Earth. They're what cause ice ages and warm ages. So solar cycles have a big impact on the Earth. So one of the ways we know about sunspots is dendrochronology, which is the study of tree rings. And basically why tree rings tell us about solar activity is because the more sunlight there is hitting a tree, the more it's going to do photosynthesis, and thus the more it will grow. So the wider a tree ring is, the more the tree grew that year, and thus scientists can indirectly deduct how much solar activity there was that year. So another method we use for, and by the way, this method goes back 11,400 years in history. So because of that, we can't really use it to go millions of back and determine the entire history of the Earth. But to determine the entire history of the Earth, we can use another method called stratigraphy. And this method goes back millions of years. And And basically stratigraphy is measuring the amount of nitrate, NO3, in sediment found in layers on the North and South Pole. Now the reason they're only found on the North and South Pole is because of the way the magnetic field on the Earth is oriented. There's basically a little minimum at the poles that causes solar radiation to go through those poles very easily. And when the amount of solar radiation increases, more of these basically energetic particles enter the atmosphere at the poles, and they go through the ice, and these charged particles, they form these NO3 compounds. So we can measure solar activity based off of the quantity of NO3 found in these composites. So another final one that we use for measuring the temperature of the Earth and solar activity is ice core records. And history shows that there's a very close correlation between the temperature of the Earth and the amount of CO2 in the Earth's atmosphere. And because of this, we can use the amount of CO2 found in the ice core records to determine what the temperature of the Earth was at that time. So, if we zoom in on this, we can see that the temperature of the Earth usually starts rising before the amount of CO2 in the atmosphere starts rising. That happens pretty much every single time here. So from that you can deduct that when the temperature of the Earth increases, the amount of CO2 in the Earth's atmosphere increases. And that makes sense because when the temperature of the Earth is warmer, CO2 exhaling organisms basically produce more carbon dioxide. So that explains why there's more CO2 in the atmosphere when the Earth is warmer. So here's another graph. This shows more recent temperature changes in CO2. And this basically demonstrates from 1880 to 2000 that both the temperature of the Earth and the amount of CO2 is increasing. And as you can see, there might appear to be a correlation. These are the only two graphs you saw. But once I show you this graph, you'll see that there's a much closer correlation between solar activity and the temperature of the Earth. And there's two things I want you to notice here. First of all, the correlation here is so much closer than the correlation here. And second of all, solar activity rises before the temperature of the Earth increases. So that means solar activity can actually be a viable reason for the Earth to increase in temperature. So basically what I'm saying is that astronomical evidence, dendrochronological evidence, stratigraphic evidence, and ice core evidence all show that the temperature of the Earth is directly caused by the amount of solar activity. So don't underestimate the role of the sun in climate change.